A self-driving car needs to know exactly where everything is. Not just what it looks like, but how far away it is, in every direction, dozens of times per second. Cameras are great at recognizing things, but they struggle with one job: measuring distance accurately. That gap is a big part of why Lidar exists. Lidar stands for light detection and ranging. It works by firing tiny pulses of laser light out into the world and timing how long each pulse takes to bounce back. Light travels at a known speed, so if you know the travel time, you can calculate the exact distance to whatever the pulse hit. Do that millions of times per second in every direction, and you get a very detailed picture of your surroundings. Each distance measurement becomes a single dot in space, a point. Stack millions of those dots together and you get what's called a point cloud, a three-dimensional map of everything around the vehicle. A point cloud looks a bit like a sculpture made of static. You can see the outlines of buildings, parked cars, pedestrians, and road signs, all rendered as clusters of tiny dots floating in space. Because the LiDAR keeps spinning and firing, the map updates constantly. The car always has a fresh 3D picture of what's around it, not just a flat photograph. Most self-driving systems don't rely on LiDAR alone. They combine it with cameras, radar, and GPS in a process called sensor fusion. Each sensor covers the weaknesses of the others. Radar is good in rain and fog but gives fuzzy detail. Cameras give rich color and texture but weak depth. LiDAR gives precise geometry but can struggle in heavy rain or snow. Together they fill in each other's blind spots. So if LiDAR is so useful, why do some companies try to build self-driving cars without it? The short answer is cost. A high-end LiDAR unit used to cost tens of thousands of dollars. Prices have dropped a lot in recent years, but LiDAR still adds hardware complexity and can be a target for damage or dirt on the road. Some engineers argue that if the human eye can drive using only cameras, a well-trained computer vision system should be able to as well. That debate is genuinely unsettled. Some teams are betting on camera-first approaches with heavy use of machine learning. Others say LiDAR's direct distance measurements are too reliable to give up. What most experts agree on is that building a safe self-driving system means handling edge cases, the weird, rare situations that don't show up in training data. How sensors handle those moments is still an open research question. LiDAR is one piece of a much larger puzzle. Understanding how it works helps make sense of why autonomous vehicles are both impressive and still genuinely hard to get right. If you want to dig deeper, look into how sensor fusion algorithms decide which sensor to trust when they disagree. That turns out to be a surprisingly tricky problem.